Okay. So today we are going to have a look at Python Dash. I'm sure everybody is excited to learn all about how Python integrates with HTML and CSS to produce delightful looking web apps. So what we're going to have a look at is overview of Dash and kind of all the language components of it, the basic structure of a Dash app, and then how you associate all the components and their functionality and try and get that running smoothly, and then styling it all with CSS, because yeah, otherwise it just looks awful. So Dash itself, Dash is a Python library, and it's kind of got several components to the library that we'll look at in a minute. And yeah, it integrates Python, HTML, CSS, JavaScript, and jQuery. We're not going to cover JavaScript and jQuery because I still need to learn a lot about that, but that's mainly for making custom components. And so you can do everything else with just Python, HTML, and CSS. And the beauty of Dash is that it can be fully containerized for deployment. And this can be done, the main one that it uses is Flask. And then that can be, the app can be containerized and then hosted online on an online server. So that makes it really practical for being able to actually scale and deploy these kind of apps for use by lots and lots of people. And another nice feature of it actually is that you can add security to it as well, and actually have people logins and passwords if you want to create a secure environment.
That's cool. Love it.
So just to give a brief overview of what HTML and CSS are for those that aren't familiar with them. So HTML is hypertext markup language, and it is the entire basis for the front end of the web. This is what it is, how people use all the standard components that all websites are built out of. And then CSS is their cascading style sheets, and they provide all the styling information for HTML components. And you do have to define everything. It defines every single aspect of the styling. And so it is something that if you're going to be doing front-end web stuff, that you do need to become familiar with CSS. And particularly now with CSS3 and HTML5, you've got responsive CSS, which means that the styling will adapt to all the different screen sizes that we have on our devices. So everything from kind of large monitors down to laptops, then down to, and different sized laptops, then tablets and different sized tablets, phones, different sized phones. Because yeah, as you probably noticed when you use websites and apps on online, kind of on your desktop and on your phone, they do look different. And when it's done, when the responsive CSS is done well, it makes it look really, really good, and makes it really practical for using your app across all different devices. So what's Dash again? So Dash is this Python-based framework, and it enables the integration of Python functionality into the HTML components. That's kind of the key element, that you can have a HTML element, and then when you click on that, or when you click it or enter something, you can have a whole lot of complex Python functionality sat in the background behind that, without having to go into doing JavaScript or Java or anything more more confusing than Python. So the online user interface is created using all the HTML components. Python sits in the background and it's all styled with CSS. And then, the advanced functionality comes through JavaScript and jQuery, but we will leave that for today. So, Dash apps themselves. The main components of your Dash app are, first of all, a Dash app object. Like a lot of kind of Python libraries and that, you create an app object that then has a whole load of different information and dictionaries, mainly dictionaries, that will sit behind it, and that you can push different information up to. One of those is the app layout, and that's your main component for where you're setting out what your app is going to look like. That's where you specify all the different components. And then we get something called callbacks. And callbacks are what are used to associate the HTML or your app components with all the functionality. And they've got a very specific syntax that goes with them. And then you have your CSS styling files. And finally, the server run command is the other important aspect of this. So there's a few elements that need to be brought together, but it's not, you can use quite standard templates with these, so it's not too confusing. So first of all, the key dependencies that we get, that we need to bring in order to create a Dash app, is the core Dash library itself. Then we get Dash core components, and these are all of the components that kind of Plotly have, sorry, I should have said actually, Dash is created by Plotly. So they manage the library, and they also have a premium service with it where you can get some additional functionality, and they also create web apps for you. But yeah, so you get the Dash core components, which is where they've come up with some tweaked or novel components that are particularly, they think are particularly useful for data science. Then we get the Dash HTML components, which are most of your standard HTML components, such as buttons, inputs, sliders, or there's whole loads of them. All the paragraphs and division components are within the HTML components library. Then there's also Dash Bootstrap components, and this is a library that's been built up independently, and that provides some additional components, or a slightly different way of, they have some slightly different functionality in them, and they sit separately to Plotly's core components, so they're worth a look at. And we also need to bring in, from Dash dependencies, we need to import input, output, and state. And these, as we'll see in a bit, are key components of the callback, component callbacks that we use for associating the components with their functionality. So next one, the first main component of our app is going to be the app object itself. And this is initialized just by assigning to a variable dash dot dash name. And actually all that you need in this is just underscore underscore name underscore underscore. That is enough to initialize the dash app object. And in all my playing around, I haven't had to extend this any further so far. And we can ignore the external style sheets argument at the moment, as we'll come back to this. So yeah, very simple, just a single line to initialize our app object itself. Then we can start adding things to our app object. And the main one that we've got to do is our app layout. So this is defined by app.layout. And so the app bit is just, yeah, our app object name, followed by the keyword layout. And then we can start assigning components to our layout. And I've just given the example here of a HTML division element. And yeah, so we've defined the HTML components library as HTML. So we're calling it from that library. And one of the biggest differences, if you've got a background in HTML programming, is that normally if you define a division element or any element, it's all in lowercase. In Dash, the first letter of all of the components is a capital letter. And yeah, if you're flicking between working in pure HTML and Dash, that can get a little bit confusing. I've caught myself out a few times not putting a capital letter in Dash. And then within every single component, whether it's in the core components library or the HTML components library or the Bootstrap library, they all have these three main arguments associated with them. First of all is the ID, and this is where you can assign a unique ID to your component. And this is necessary for when we're wanting to associate that component with some functionality. And so we need IDs to be able to identify the component in our callbacks. Then there's the class name, and this is where you give the CSS, any CSS classes that are associated with that component. And you can give as many classes as you want within that argument, and they are just separated by space. And then the third argument, and arguably the most important, is the children argument. And this is a list of everything that then sits within that component. And we'll see how this is used in a few different ways within the code itself. So what we're going to do with this is basically build up a hierarchy of elements. It's a hierarchical programming structure, as we'll see in a moment. So I'm just before we go and look at the code, I'm just going to go, the last one to mention is the server run command. And this basically says where you want the app itself to be running. And this these two lines are the kind of standard way of getting an app to run on the development server, which you use for when you're working up and building the app itself. So that's just saying if name is equal to main, then run it on the deploy on the development server, and we've got debug as true. So that will show us any errors in the web app itself, and we'll see an example of that. So if you'd like to open the basic layout example file, .py file, and if I get mine open, there we are. So in our basic layout example file, we can see at the top, we've got our importing our dependencies, which in this instance, we've got dash core components, and dash HTML components. And then what I've put in here is an external style sheet. So people put CSS templates up online, and there's quite a lot of them to be able to choose from. And they're quite good when you're just doing something for yourself, or some starting out and just having a play with Dash, just to give you some initial basic styling, so that you get some decent fonts, and everything isn't all squashed together. It gives some segmentation between things. And so anything which is provided above the app object will only be run once in the app, and we'll see why this is important in a bit. But anything above this, where we define our app equals dash name object, that will be run when the app is initialized. So you can calling data and do some pre-processing on the data set, and you can do that once by defining it here, where we got the where the style sheet is, and anything you just want to be initialized at the start of the app. So we initialize our dash app object, and in this instance, we're calling in an external style sheet, and which is just called external style sheets, and that just provides a little bit of CSS for it. Then the next bit is the app layout, and this starts with a division element, and then as I'll clarify in a bit, we define another division element and place our header within that. So H1 element is a large header, piece of header text, and within the children element, we're then giving we're then passing what we want into that element. So in this instance, it's text, a string of text saying my first web app. Then after that, we've got another division element, and we've got some text. And in this instance, it's a P HTML element, which is a paragraph element, and we're passing some text into this. And then below that, we've got some more text, but within that, we've also passed in a HTML element, which is a text link. So this takes some arguments, which one of which is href, which is the hyperlink reference, and that's your web address. Provide a target if we want, and in this instance, it's a blank tab. It'll open a new tab. And then we define our children element, which is the text that will be displayed. and we'll see how this all looks in a minute. The arguments that are passed into any of the HTML elements are the standard HTML arguments. So there's loads of information online about what all of the different arguments are that are associated with each different HTML element. And so they've done a really nice job of keeping it very, very similar to what the standard HTML syntax is, which makes it much easier regarding documentation and actually looking things up, which is one of the bonuses of this, that it's not all kind of custom syntax. You don't need, they haven't had to produce loads of custom documentation. So after our bits of text and our links, we've then got another division element, and within that we've got one of the dash core components, which is an upload object. And here you can see I've assigned the ID as upload object, or upload object, and then within this we have another div, and we pass in some text saying drag and drop, and then a link saying select files. And this is kind of the standard form that these upload objects take. And by passing a link in to the upload object, it knows automatically to open the file browser. And that's kind of one of the really nice bits, again, of Dash, and where they've tweaked some of the components and created some novel components that make it very easy to, for example, bring in an upload object where you'd have to specify additional arguments to say, oh, I want you to open up the file explorer. Here, by just passing a link in, it knows to open up the file explorer. Then below our upload object, we've then got a data summary. So you might be able to tell we're going to be passing some data into this app, and then it's going to summarize the data for us. And we've got a paragraph component saying below is a summary of the data we've uploaded, and the callback is automatically triggered when the data is uploaded. But below that, where you think you might have a table, what we've got is actually a summary table container, because we're going to create the table within the callback separately and pass it up to that container, so that there's no kind of empty table just sat there. And then below that, we've got a graph component. And because this has been developed by Plotly, it's got a heavy emphasis on plotting and graphs and interactive graphing and data exploration. So their graph objects take a wide range of different types of graph, and you can use a whole load of different graphing packages, whether that be Plotly, or you can use matplotlib, and you can also use, it works with hollow views. Those are the main ones at the moment. Pretty sure that those graph objects will take nigh on all different types of graph, no matter which Python package you're creating the graph in. And then below this, we've got our server run command, and that sits outside of our app layout, and that's kind of the bottom. That's the final thing that should come in your code. So let's have a go at running this. So to run these, you just run file, and run the whole thing at once, what you should see in your console is that it comes up saying that it's running on and giving a web address. It provides a debugger pin, which I haven't found any useful so far, and that it's throwing it up to the development server. So all we need to do, we can copy this, and I recommend you have to use right-click copy, because Control-C will exit the app running. So if I bring across an empty window, we can paste in our web address. And hopefully, there we are. And hopefully everybody's seeing the same thing here.
Yes.
Yeah. Already looks more advanced than anything I've done on the web.
Yeah, and so we start to, hopefully this will start to give you an idea now that that we use, this is the idea of the hierarchical order of elements. So we first defined the H1 kind of header element up the top, my first web app. And then we had some text and we had some links in that. And we can click on one of these links and that'll open in a new tab. And just to say, this is, so what I've done is I provided links to the main documentation for Dash. Here you've got Dash core components here, and it's got some great documentation and examples with it. And there's loads and loads to go through if you want to get into this kind of app development. There's really good tutorials to get you going, explanations of callbacks because they get quite complicated. And here we see a list of all the different core components that we can have. So everything from checklists, confirm dialogues, drop downs, graphs, inputs, location elements, radio items, sliders, date pickers, tabs, everything you can think of.
That's really nice. I like that.
And then in the HTML components, we get a list of all the HTML components that are associated with it as well. And I mean, that list just is quite significant, but everything, video, text areas, everything that you'd expect normally to be associated with web development, all the little buttons, spinners, nav bars, everything that's all there and available for you to work with. And then we also get the Bootstrap components, which, as I said, have been developed separately. I can't remember who's developed this, but yeah, they've got additional components here. So some different types of button groups, cards, which are quite a big thing for dashboard development. I don't find them particularly useful. I'd rather use sections, but yeah, some people like cards. You can display different information in them and they can be moved around. Yeah, forms. The Bootstrap components make it much easier to build HTML forms. Their nav bars are quite good as well, and they've got a lot of progress bars, and their table component's a bit better than the standard HTML component one. Yeah, there's actually within the table that you can do table from data frame, very easily. So yeah, there's some good functionality within that. So so this is kind of our basic layout, but yeah, we can't really do, nothing will work if we go to this select files hyperlink, which opens up the file explorer, as we said, and I try to load in some data, it just doesn't do anything. We haven't got any actual functionality in our app yet. So that's the next thing that we've got to do. So to end the app, we can just close the tab, and then in our Spider console, press Control-C, and that will exit the app running. So just taking a pause, are there any questions at the moment? No. Sounding good, excellent. Everybody's either asleep or following along. So moving on to callbacks. So now we've got to put some functionality in our app, and callbacks are all done in this standard way. It uses the @ symbol followed by our app name, which for ease in this instance is app, and then .callback. Then we have we first of all define our output of the callback, so what we want to be where we want to be passing things to. Then we have our input, which is what's coming in, and then state as well, which is handy, and I'll explain a little bit more about that in a moment. But then underneath we define the functionality. So we just, as you normally would, you define a function, given a function name, and then our inputs. And our function inputs are input variables are anything that is input in the input callback argument and the state. However many inputs and states arguments you have, you must have the same number of input variables into your function. And so then we define what we want to be done with our variables, and a return statement, and returning our outputs. So the output is so the way that this works, and why it's really important that we have unique IDs associated with any component that we want to do things with, and to attribute functionality to, is that we use the component ID, which is the ID argument of our component in the layout, to identify it. And then we provide an attribute input. And so each component has a whole list of attributes, which are all documented as I showed you on the dash. And we can go back and have a little look at some of the components and the different values that you can, the different attributes that you can pull out. But that's, yeah, so you assign component ID and the attribute that's either being input or that you're outputting to. Yeah, so the input is where the function outputs will be passed from, and state are attributes. They're only passed from state-defined components when the input is triggered. So this is really handy, for example, where you've got an input box and a button associated with it. and you want to pass in the a text string value from the input box, but you don't want it to be passed in every time a button is pressed as somebody's typing into it. So what you can do is that you associate the button as the input. So when the button is clicked, it will then look at the state of the input box and pull it in then only on the button click, not when the input is activated every single time somebody presses the button. So that's the subtle difference between inputs and states. Input are activated every time that an element is activated, and state is only activated when it's asked to be. The input and state variables are passed to the callback function as input arguments in order. And this is really important. So yeah, this this ordering, this input would be variable 1 and the state would be variable 2 here. So, right, yeah, this is easiest if we have a look at have a look at some callbacks, get some actual examples. So if we go to the basic callbacks example.py file, what we can see here now is that we've got our code as before, our dependencies, and there's some additional dependencies because we're starting to do stuff with within our app. And we've got our upload object, we've got our summary table container, the graph object, and I've also added in a drop-down component, and we've assigned an ID to that, ops drop, and a storage component as well. And I'll talk a little bit more about them in a bit. And I've just provided a link as well to where the data source. We're using a Kaggle data set for this, looking at hospitals and beds in India by state. So coming down the file now, what we start to see is there's a series of functions here. We go down a little bit further, we've got our callback, and it's easy to pick out. We've got our app.callback, and then we've got a series of outputs and inputs and a state as well. So what we want to do within this app is to be able to upload some data, have perform some calculations on that, and get a summary back of the data, and then graph the data. So this callback and these functions are going to enable us to be able to do that. So what we're going to pass out as our outputs are going to be a summary table, and we're going to pass that to the summary table container. We're going to pass out a graph, and that's going to be passed to the graph container. We're going to pass out some options to the drop down to enable us to subset the data and view the subset data within the graphs, and pass out our uploaded data to a storage component, so that it's available to be used by other components should we wish to. So our inputs here are going to be the contents of the upload object, the value of the dropdown for subsetting the data, and the file name of the uploaded file. So, and one thing that you'll notice here is that all of these output, input, and states are lists. Input and state must always be given as lists, even if there's only one of them. So you can see there's one state, but it's still contained within a list. Outputs, however, if there's only one output, it doesn't have to be given as a list. But if you've got more than one output, then you contain it within a list. So what we're going to do is, so this is upload table and graph it. So just called upload table graph. And so we've got two inputs and a state. So that's our data coming in, the option, and the file name. And one thing that happens with Dashat is that every time something is triggered on a page, all the callbacks are triggered, or any callback with a component, an input or output that is associated, that's being activated. Every time that they are activated or the page is refreshed, they will trigger. And this will start throwing errors if, for example, you haven't got your data in there already. So here we say if data is not none, then I want you to do something. And this is one of the ways that we can handle this this constant updating that Dash does, and stop it throwing too many errors because it hasn't got the right information, because, well, it hasn't been uploaded yet. So this is where we can start defining what we want to do within our app. And so here we want to, we're going to call the function import contents. We're passing the data, which is our going to be our CSV data file, and the file name of that file. And if we go up to the import contents function, basically this, the upload object brings it in, brings the data in as a binary file. And so it needs to be converted to, say, it's comma delimited file, and in base 64. And so we do a little decoding on the data first of all. And then just showing an example of kind of some of the background stuff that you can have in here that's handy to have, and that I had this function made already. That if it's a CSV, then it does read CSV, and if it's XLS, then it will do a read XL. And if it's neither of those, then it will throw an exception. But this just basically imports is your standard, in a way, standard Python function just to import some data. And so that then passes out the pandas data frame to the variable df. And then we go down, if df is not none, we go on and we create a summary table. And so we're just passing the data frame in and getting some some means, some median, standard deviation, minimum, maximums, and putting that together as a table. And what I'm doing here is that from the Dash Bootstrap components, I'm creating a table from the data frame. Just a very simple call, and that automatically converts my my data frame that I've created above into a table component, into a table object, and attributing that to summary table here. So we're able to create these Dash components separately, and then we can push them up to our layout, which makes it quite easy, quite flexible, that you don't have to have everything in the layout. You can have a container for something, and that if it's required, if the function is triggered, that you might not want a table. It might be optional, or there might be multiple different tables that can be created depending on something that somebody's selected. That you can create the objects within your callback functionality and pass that up to a container that's waiting for it. And then we're going to, once we created the table, we also generate some options based on that, based on our data set. So in this instance, we're just getting the names of the columns and putting that into a list of dictionaries. So options for drop downs are given in the format of label and value. So that's your dictionary, and then we create a list of these which can be passed up to our drop down object. Once we created our options, then we can go on and create the graph itself. And here we are saying that if the options, if an option has been selected, then I want you to render the graph with that selected option. We're passing option in as our Y component of our graph. And here we're using a Plotly, creating a Plotly bar chart. And then we can create a graph object, attribute our figure to it, and return that graph object. So when this is first triggered, there won't be an option that's selected for the graph. So to account for that, just put in if there isn't an option selected, then use the PHC column of the data and create the graph based on that. And then our final, in our callback function, our final line is just to create a dictionary from our data frame, as the storage, the data store component where we're going to put our data takes a dictionary. It won't store a pandas data frame. So there's some little quirks around all the different components and the format that the data has to be in when you pass it up to it. And then we were returning four different things here. We're returning our summary table object, our graph object, our options, and our data in a dictionary format. And that's just your standard syntax for returning multiple options out of a function. So it's all very, very Pythonic, this, which makes it quite intuitive if you're used to Python. So I think the best thing to do now, let me just see what we've got here, if it's worth going back to here. Come back to that afterwards. So I think we should run this now and see how some functionality works within Dash. So if you run the basic callbacks example.py file and you can bring yourself up the web browser and navigate to the address 127.0.0.1:8050. And now we can click on our select files link and navigate to where you've got your data set. So data sets, in fact, actually, if I do it, so I've gone into my Git folder where I keep my clone repositories, dash intro, and get the CSV file, and it will automatically generate a summary of the data and a graph and a drop down with the different columns that we have available to us. And in the next example, I've tidied this all up and we'll know what PHC, CHC, SDH and DH stand for. But if you click on the different options, you'll see the graph update itself and change. So this is quite nice, a nice example of just some interactive graphing. And because Plotly, because they've designed all of this to be used as kind of web interactive data exploration tools, you get the nice hover on it, and you can see what the value is, and you can get it to show all kinds of different information that's contained within your data set within the graph itself. So I'm just going to stop there a moment. Any questions or anything?
That's looking good. It's all working.
Yeah, all working. Excellent. Brilliant. So just pushing on a little bit. So some really key bits about callbacks, as they do get a bit quirky. It is an explicit one-to-one passing of arguments, that a component can only be the input or output of any one callback and not both. So that's quite a constraint, and it can make it challenging sometimes thinking about how you link components together. And yeah, sometimes it can result in quite you've got to chain callbacks together or use different components than you might have originally have wanted to, because of this limitation. A component can only be the output of one callback. Again, yeah, you need to use kind of larger callbacks, chained callbacks, and storage components to overcome that. Callbacks will update every time a page refreshes or a component in the callback is activated or updated. Yeah, and you can see that where calling, if it's not none, to try and prevent some of that, it throwing an error by trying to run functionality for which there isn't, the information hasn't been passed to the component already. And additional functions can be called within the callback. So your functions can be used in multiple callbacks, and it also keeps the callback function itself shorter if you separate out your functions from the callback and use the callback just to call functions. And yeah, kind of keep that quite tight and just its own. It's just calling all the different transformation functions that you're using. Okay. Right, let's, the moment you've been waiting for, a bit of CSS. Okay, so CSS can be integrated into these in a variety of ways. As we've seen, our examples have been using an external style sheet, and these can have web or local addresses and can be passed directly into the app object at the beginning of your code. The one that I had there was just quite a simple example and just provided some basic default styling. You can use the style argument in the component. So this is one of the, each component will take CSS styling information directly. This is not recommended because it's a one-off. You are just styling that single component, and you're better off writing a CSS document and creating actually having some kind of generic component that you can use, some kind of generic CSS style that you can pass to that component. So yeah, using CSS document is the recommended way of styling Dash apps. And what you do is within, as you'd have seen when you downloaded the repository, within that folder is a folder called assets, and Dash automatically looks for this assets folder, and there's a few different things that you can put in the assets folder, including data, all your data, any JavaScript stuff, and any CSS bits, and it will automatically find that. You can also, I think it automatically recognizes JSON, so you can have a JSON folder for anything that you're doing with that for pipelining. Yeah, there's a set folder structure for as you build more complex and larger apps that Dash is kind of set up to recognize. But that it all gets a little bit more advanced, but using assets and CSS is a good start. Okay, so when creating a style sheet, what do you need to include? So a body class, which sets up some default parameters, generic component styling, specific component styling. So difference here between generic, we're saying, so things that are passed to, for example, every link, or to all text, or all drop downs. But then sometimes you might want to style a particular section of text differently, and so you can come up with a specific component style for that. A grid layout template, and we'll look at that in a moment, is a necessity now with HTML5, and all of your fonts, colors, placement information, everything has to go into the CSS style sheet. One bit of good news is that there are quite a lot of very good CSS templates out there. and I'd recommend looking at this group called Bootstrap, who have got some good kind of templates for CSS styling, which are already set up with responsive CSS as well. So it will give you an idea of what you need to be including, and a lot of generic classes that you can use. So within a CSS file, you define your different classes, or CSS selectors is the term that's used. And there's a number of different selectors that can be used. The first is universal, so it's applied to everything on a page. So the asterisk. Type selector is applied to all elements of a given type. So for example, H1, which header size 1, and you just put the name of the component, the element name for that one. You can define your own classes, and these just have dot and then your class name. And so then you can go through, and within the class name arguments of the component in your layout, you give that class name, and that will apply that CSS styling to that component. We can then style specific components of a class by using so the component, so a paragraph component of the class, and then a specific class name that you give it. You can also style components by ID using the hash. And there's a number of others, a few others, which, to be honest, if you're getting to the point of using them, then you're probably quite far on with understanding CSS. But there's a whole lot of dependency and inheritance within CSS, the CSS structure, which gets very confusing, and is something that we can always go into if people want to, would like a session on, an extra session on CSS. Okay, so I think the best way to do this, actually, yeah, I'll just talk through this quickly, and then we'll look at the CSS file and how that's integrated into styling the Dash app. So kind of rule of thumb for element order and how to structure your app, and kind of how to think it through, because this is what took me a little while to get my head around. You need to partition everything into horizontal sections. So across, kind of going across the page, thinking about everything as horizontal sections, because everything is in this kind of hierarchical order. And doing that by objects that are grouped together. So yeah, kind of thinking about your app as a web page, as sections going down the page, or yeah, we'll go with down the page, that's easier. So thinking about partitioning everything horizontally, and apply section formatting. So it's kind of padding and colors, and each section should have some standardized wrapping around it. So that's kind of your borders and margins around the side, any coloring, any padding on the top and the bottom to separate elements within each section. And this is where the division container elements become really, really useful, because these can be used to set different levels of different levels of standardization and containerization within of your components. Use standardized padding, container and row classes, and use them in, that tends to be the order from what I've found so far, is basically you pad something, so moving it all away from the edges and the top and the bottom. You then wrap it in a container to say, okay, this is going to be all the stuff within this padding, and then you give it as a row to say, okay, this is all going to be kind of these are rows of stuff, and then you add, this is a row of stuff, and then you add your component elements. Don't try to put too many elements in a single container. It's better to use more containers than too few. Elements. So one thing that catches people out with HTML and CSS is putting stuff next to each other. Things don't necessarily want to go next to each other, they want to go underneath. So there's a display inline, which works in some circumstances, so particularly with lists. You can create a nav bar from a list by using display inline, and it will, instead of having a horizontal, a list going down the page, it will put the list across the page. But yeah, that works in certain circumstances, but the best way to get stuff next to each other is to use the grid layout, and we'll have a little look at that now. So what I'm going to do is see if I can open it in Spider. Actually, I'm just going to open the CSS file. Yep. And so, as I was saying, you've got the body call at the top, which here we're given kind of a default background, color to the text, font size, font weights, line heights, letter spacings, how overflow is dealt with on the screen, some basic margin and padding, and all of these get a little bit more confusing with I need to work out what they all mean, but they tend to be used as standard. There's lots of stuff we pick up and just go, oh, hang on, that, yeah, they make that work. And then what we got here are specific styles. So these are for particular elements. So H1, H2, H3, kind of setting up our headers and our paragraph and link components. And so this is attributing their font type, their weight, color, and font size. And then a neat one is that with links, when you hover over them, so in a lot of the time, they kind of shift and change. And so CSS does make this quite easy, that you can use a hover and you can change the color. You can also do animation and smoothness and then all sorts of fancy things with that. This footer argument is an example of a specific named class. We've got the dot, so this we would write as the class name footer, and we could use that text setup. Now here we've got kind of three really important elements that I was saying about. So container padding, containers, and rows. And so padding tends to be used for padding top and bottom of a section. You tend to have a pad section class, and that's keeps it all very standardized. You don't want to pad every section individually. We then have a container, which is set to display everything as an inline block, aligned to the left across 100% of the page, with a margin and padding on the left and right. And we'll have a little bit of a closer look what this actually looks like in a minute. And then our row is saying just flex the display. So that means that if things are overrunning on your monitor, that it will flex and move that and change, adjust the gaps between everything. It's not absolute. It's trying to get everything as flexible as possible. What's we got here? Oh, there's all sorts of stuff to look through there, but a lot of it revolves around aligning, padding, margins, and text positioning. This here, where we've got our grid layout, in CSS layouts, it uses, they say the best way to do it is using grid layouts. And this is a standard template for creating columns. And the way that it works is that the whole page, a web page, can be split into 12 columns. And the idea is that if you've got 12 columns, that's 100% of the page. And then everything else is a proportion of the page. So you can set something to a width of 2 or 3 or 4 column width, and then put something else next to it, which is 2, 3, 4 column width up to 12 columns. So it's just a way that you can put 2 or 3 or 4 components next to each other. But yeah, it takes a little bit of getting your head around this kind of column layout, but that's something that we can look at in another session, should anybody want to. But I think the important thing now is to have a look at how we input these IDs, class names, and how it all comes together in the in our app. So you'll be pleased to see there's not loads of additional code yet down the bottom, but up the top, I've put in all the necessary division elements to set this up as kind of a well-presented kind of app. So you've got a lot of division elements, and here we're using this this ordering of padding, container, and in some instances row as well. So pad, color, and contain is kind of a way to think of this. And here so we're splitting down in our first kind of container. All that we've got is the title, but it means that the title is containerized and wrapped and padded properly, and it's not squished in with anything. It seems like a lot of code just to be able to put in a title, but it does look nice at the end of the day. As we come down, kind of containerizing everything together, thinking about everything as a section. Our header is a section, the our text is a section. The upload object is a section. Header for the upload data summary. Each thing is as a separate horizontal section. Keep everything nice and tight. And so different styling. We've got our class name argument in our division elements. So for graph options, for the graph itself, is using this class name container. Sorry, our class name argument. So let's run this and see what it looks like. Ooh. So we've got something which is, it's not all squashed to the sides, it's all quite nicely centered, and got nice section differentiation across using colors, headings, everything's of an appropriate font and font size, font weight, and we've got this nice dotted line around our upload object. So when we upload that, our table comes out, and we've got our graph, and we've got a bit of styling on the graph, and nice. Our box is much nicer, and I've put in what the different columns for the data mean. So community health centres by state across India, and we've got a kind of a heat map colouring to it. And that's it. That is how you build an app in Dash. CSS things to be aware of. Grid layout.
It's good to have the templates.
Yes. Yeah. Absolutely. Absolutely. Seeing how it all comes together as a whole file, and seeing, particularly with CSS, the templates to understand what are the core and the really key components, and the kind of order that you need to be using them in, because it does get quite fiddly and quite specific with that. And actually, if just show you a really useful way to learn about how this all works is to use the right click on any web page and use inspect.
Oh.
Go in and actually look at the HTML code behind, and what it'll also show is all the CSS, and you can see where the padding is. So this pad section, color section, relates specifically to that, the blue and the green bit at the top. The blue is our component, and the padding is the green, and we can see that that's 30 on the top, 20 on the bottom pixels. Colors are given, widths, the display type, and so if you see something nice on a website, you can go in and you can look at how they're putting that together and styling it, and get some ideas.
Yeah, I guess that's a nice thing about everybody's website. I'd forgotten about that you can inspect the code for. Yeah,
really, really useful part of that, actually. And it makes it much easier for working out what's going on within your own site, because when you're building it, sometimes you think you've got something in the right order, but because of inheritance or dependency, it's pulling in the wrong, something's being overwritten, and it's pulling in the wrong option, wrong styling option. So yeah, I hope that was useful.